This is the first video on fluid mechanics. So this is the branch of engineering which deals with fluids. So first I'll define what is fluids. So fluids are matters which are capable of flowing, under the action of shear force. So this is the definition. So matters which are capable of flowing under the action of shear force. Alright, so we can classify the matters into three categories. So matters: solid, liquid, and gases. So here this liquid and gases is considered to be fluid, whereas solid is a separate category here. So in case of fluid, the liquid is incompressible since we cannot compress it, whereas if you see gases, it is compressible since it can be compressed under the pressure. Next thing is, what is the basic difference between solid and liquid? Solid, if you see its deformation, the solid will undergo static deformation, whereas liquid will undergo dynamic deformation. So this is very important since this will lay the foundation here that how the liquid behave. Liquid deformation. So in case of solid, take a solid block here which is fixed on a surface, fixed here. Now if I apply some shear force, the solid block will deform and will get new shape here. This is how it will deform. So this is the new shape of the solid block, and the deformation we can measure here with the angle over here. So this will give the deformation here. Now if you see that at the end of the deformation, this solid block has attained a state of rest. Now it is in a state of rest. Further it is not going to deform. So since it is in a state of rest, we can call it a static deformation. Since the word static, it means at rest. Whereas in case of liquid, take some liquid here. So these are the different layers of the liquid, and this is on a surface over here. Now if I apply some shear force here, you can see the layers of the liquid will start to deform. Rather, I will use the word displace, and they'll displace in this direction. The rate of displacement will vary for all the layers, and I'll say what is the reason for it afterwards. So this is how you can say it has displaced after some period of time. Further, after some more time, if you take some more time, you'll say that further they are displacing, and after some more time, further they are displacing. So you can see that they are in a state of motion. Once some shear force is applied, they are in a state of motion, and the displacement is varying with respect to time there. So this is why this is referred as dynamic deformation, where the word dynamic, it means motion. After this, we'll see some of the properties of the fluids. The first one we'll see is the mass density. Second one we'll see is the specific weight. Third one is the specific volume, and fourth one will be the specific gravity. So we'll start with the mass density, that is denoted as rho. So the mass density is actually mass per unit volume, mass of the fluid per unit volume of the fluid, and its unit is kg per meter cube. The second one is the specific weight, and this is weight per unit volume. And since it is the unit since we have weight here, so we'll write kilonewton per meter cube here. This is the basic difference. In case of mass, we'll get kg, and in case of weight, we'll get kilonewton. Third one is the specific volume, and it will be volume per unit mass. Volume per unit mass. So you can see that this is just the reciprocal of mass density. So I can write this will be 1 by rho, and this unit will be meter cube per kg. The fourth one is the specific gravity. Specific gravity. The specific gravity is actually equal to the specific weight of the given liquid divided by the specific weight of water. So the specific weight of given liquid, we don't know what it is, we'll just keep it. Weight of liquid divided by specific weight of water is 9.81 kilonewton per meter cube. So no need to bother about the unit here, so just leave the unit part. So if we divide this the specific weight of liquid by 9.81, that is the specific weight of water, we'll get the specific gravity. The specific gravity is also referred as relative density. Relative